Alright, ladies and gentlemen, I want to go through the answers to the shorthand configurations and the Lewis dot notations for the electron configuration worksheet. This was Thursday night's homework. Let's take a look at the elements we need to do. We're going to take a look at calcium first. So calcium's location is right here on the table. Again, there's two ways that you can do this. The first way is to go to the end of the previous row. So go up one and go to the end. Put that noble gas in brackets and then finish the rest of your configuration, which would be, in this case, 4s12. So argon in brackets 4s2. Or if you already have the electron configuration written out, work your way backwards from right to left until you hit a P6. The first one we hit is 4s2, that's the end of our configuration, and then we hit 3p6. What element is in the 3p6 position? 2p, 3p, 1, 2, 3, 4, 5, 6. So again, argon in brackets would be everything through 3p6. That's what argon is. So calcium is, in shorthand, argon and 4s2. Lithium would have a configuration of 1s2, 2s1. So we would take a look at lithium. We would go back to the previous row and go to the end. Helium would be our noble gas. And then 2s1 would be lithium. So 1s2 is helium's configuration. So lithium is helium and 2s1. Iron is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Go backwards until you hit a p6. We get 3p6. That's argon. End of the third row. Put argon in brackets and then the rest of your configuration. 4s2, 3d6. And make sure it stays in the filling order. Don't put the 3D first and then the 4S. Some charts will tell you to do that, and that is wrong. We always want to keep your filling order intact. So if we would write the configuration 1S through 3D, we would want to keep the 4S2 and the 3D6 at the end. Sodium is in the third row. It's the first element in the third row, so we're going to go to the end of the second row, which is neon, which is 2p6. 2p6 is neon. Sodium is everything that neon is, and 3s1. Oxygen. Oxygen is helium and 2s2, 2p4. So we put helium in brackets, 2s2, 2p4. And again, here's oxygen. Go to the end of the previous row, write that noble gas in brackets, and then finish the rest of your configuration, which in this case would be 2s2, 2p4. Alright, oxygen, iodine. So iodine goes all the way through 5p5. Okay, all the way through 5p5. So if we look at iodine here, go to the end of the previous row, we're going to put krypton in parentheses, or brackets, I'm sorry, put krypton in brackets. And then this is the 1, 2, 3, 4, 5, 5s2, 4d10, 5p5. 1, 2, 3, 4, 5. So you can take your element, go to the end of the previous row, put that element in brackets, and then pick up your configuration. 5s2, 4d10, 5p1, 2, 3, 4, 5, and that will be your configuration. Krypton, 5s2, 4d10, 5p5. Let me zoom in on the rest of these. They're a little bit longer, but if you look at your configurations here, sorry, one too many zoom ins. Look at your configurations for osmium. We did that configuration before, so work your way back. You hit 5p6, so that's xenon. Xenon is the end of the fifth row. And then keep everything else after the p6, 6s2, 4f14, 5d6. Xenon, 6s2, 4f14, 5d6. Radium is at the end column in row 7. So that's almost all the way through the end. So we're going to go to the end, which is 6p6 and 7s2. So 6p6 is radon, right there, the end of the 6th row is radon, and 7s2. Fermium would be all the way through 5f12. To find the noble gas for fermium, remember that this is actually the 5f, which is in the 7th row. So we're going to go to the end of the 6th row. We're going to put radon in brackets, and then we're going to do 7s2, 5f12. So radon in brackets, 7s2, 5f12. Write out your configuration, go backwards until you hit P6, and then anything beyond that you want to keep on the other side of your brackets. And then argon. Argon is a noble gas, but you can't just put it in brackets by itself. You got to go to the end of the previous row, which would be neon, 3s2, 3p6. Okay, 3s2, 3p6. All right. Now, the next thing that we were asked to do was to figure out the valence electrons. So those would be those that have the highest number out front of the letters. So if we go through calcium, 1, 2, 2, 3, 3, 4. So the only electrons that are in the 4th level, which is our highest number, are the 2s. So you would have calcium, and then put 2 dots, one at the 12 and one at the 3 o'clock position. We have 2 electrons on the 4th and outermost energy level. Lithium. Lithium, 1, 2. How many electrons are in the 2nd energy level? Just 1. So we'll have lithium. And I'm going to do X's for every other one just to keep them separate. 1 dot. And you could really put that at any one of those clock face positions. Iron. If we look at the numbers out front, 1, 2, 2, 3, 3, 4, 3. So what electrons are on the highest number for just the S2? We would have 2 valence electrons. Okay. Sodium, 1, 2, 2, 3. We only have 1 electron on the 3rd energy level, so we would have Na symbol with 1 electron. Okay. Oxygen, 1, 2, 2. We're going to take all the electrons in the 2nd energy level, which is 2 plus 4, that's 6. So we'll put oxygen symbol. Then we'll do 1 at the 12, 1 at the 3, 1 at the 6, 1 at the 9. And then start to double them up. 2 at the 12, 2 at the 3 o'clock. Make sure that they are notably paired and unpaired. Iodine, 1, 2, 2, 3, 3, 4, 3, 4, 5, 4, 5. 5 is our highest number. We're going to add those superscripts together. 2 plus 5 gives you 7. And we have iodine. And we're going to have 1, 2, 3, 4, like that, around it in the clock face positions. Put the 5th one, pair it up. 6th one, pair it up. 7th one, pair it up. And then we're done. We have 7 valence electrons. The valence electrons, remember, are the electrons in the outermost energy level, which are represented by the highest number out front of the sublevels in your electron configurations. Osmium, 1, 2, 2, 3, 3, 4, 3, 4, 5, 4, 5, 6, 4, 5. 6 is our highest number. There's only 2 electrons in the 6th energy level, so we have capital O, little s, and I'm going to put those dots at the 12 and the 3 o'clock position. Okay? Radium. Radium, if you look through all the numbers, our highest number is 7 out front. There's 2 electrons in the 7th layer, so we're going to go capital R, little a, and we're going to go at the 12 and the 3 o'clock position. Remember, each clock face position gets 1 before any get additional. Then we go through fermium, we go through all the numbers, and our highest number is 7. 7 only has 2 electrons in the S, so we put Fm for fermium, and we put a dot at the 12 and a dot at the 3 o'clock position. Finally, we have argon. Argon has
The third energy level is its highest. 3 is your highest number. 2 plus 6 is 8. So we're going to go argon. We're going to put 1 electron at the 12, 1 at the 3, 1 at the 6, and 1 at the 9 o'clock positions. And then we're going to start doubling them up. We have 6, 7, 8 electrons. 8 is the highest number of valence electrons that you can have. If we look down here at number 15, you have 4s2 and 4p2. That's going to give you germanium is going to have 1, 2, 3, 4 valence electrons. Lead, if you look through all of it, you have 6s2, 6p2. 6 is our highest number. We're going to have 1, 2, 3, 4 valence electrons. And then our last one here, 3s2, 3p5, that's 7. So we're going to put 1, 2, 3, 4, give every clock face position a single, 5, 6, 7. Make sure that they are definitely clearly appearing as being. They need to appear as being paired up or unpaired. And then fluorine has 7 as well. We're going to put 1 at the 12, 1 at the 3, 1 at the 6, 1 at the 9, double up the 12, double up the 3, double up the 6, and we have 1 unpaired electron. I'm going to put a couple tutorial videos at the bottom of this, underneath this video. So if you're having any trouble with Lewis dot notations or shorthand notations, please look at those tutorials to help clear you up. I will answer any questions we have on Monday, and then we're just going to do an activity Monday and Tuesday that will act as your quiz for this section. Please make sure that you submit your work from this week, and make sure all your assignments are done and you meet the deadline.